Hello everybody, we're getting ready to do lesson 2.1 part 2 of pre-calculus math today. Contact me here, here's my contact email. 2.1 part 2 classwork, 34 points, note-taking guide. If you need those, contact me for those. We have 34 points, then we have 0 points of notebook taking today. And teachers, here's today's bell work. In exercises 25-26, describe the graph of the function, of this function here, and identify the vertex. Use a graphing utility to verify your results. So, describe. These are description boxes here, and then use a graphing utility to verify your results. Give your students about 6-7 minutes for this. Okay, welcome back for our solutions of today's bell work for 25. 25 would be x squared minus x plus 5 over 4. We're going to complete the square here, and so it'll be negative 1 squared, which would be 1 over 4. And then we add that to outside the parentheses here. Be a negative 1/4 out here too. And then we find this is a perfect square, x minus 1/2 squared. And then 5/4 minus 1/4 would be 4 over 4, which would be 1. So now we got this in vertex form here. The parabola would open upward because a out here is positive. There is a implied a out here, which is positive 1. And then our vertex would be the negative of 1/2, which would be 1/2, and then 1. So your h and k would be 1/2 and 1 for 25. And then down here for 26, we're going to complete the square down here. So we collect our x's together here, group our x terms here, and then put your 1/4 outside the parentheses. Take 1/2 of 3 and square it. We get 9/4 here. And then we subtract 9/4 outside the parentheses. That's usually a step that students will get confused on. And then here we have x plus 3 over 2 squared minus 2. So 9/4 minus 1/4 would be a negative 2. So again, we got it in vertex form here. And as the parabola opens upward again, your a out here is positive 1. And then your vertex here would be negative 3 over 2, negative 2. That would be your, this is your h and k here. So students, you should have that. Okay, into our first example here. Page 1, example 4, writing the equation of a parabola in standard form. Write the standard form of the equation of the parabola whose vertex is 1, 2, and that passes through the point 3, negative 6. So to do this, the vertex of the parabola is 1, 2. The equation has the form of f of x equals a times x minus 1. This is your 1 here, and then squared, and then plus 2. This is our k member out here. Substitute h and k in standard form. Then because the parabola passes through the point 3, negative 6, we know this is a point that it goes through. It follows that f of 3 would equal negative 6. Yes? So when we plug in 3 here for x, we'll get a negative 6 on this side of our equation. So here is our standard form of our quadratic here in vertex. So when we do that, we can say negative 6, a 3 minus 1 squared plus 2. We got to find out what our a is here in this case. Substitute negative 6 for f of x and 3 for x. So we get negative 6 equals 4a. 3 minus 1 would be 2 squared is 4a times a plus 2. Simplify. Negative 8 equals 4a subtract 2 from each side, negative 2 would equal a. Now we got a better idea of what our quadratic is going to be. The equation in standard form would be negative 2 times x minus 1 squared. We just plug that in up here, plus 2. And what does that graph look like? Here's your graph of this quadratic right here. Then here is your vertex, so it'll be 1, 2, and then you have, this is your point down here that we plugged in to the standard form to find our finished quadratic, which is here. Okay, let's do one now. Vertex is negative 2, 5, and then we have 0.09. Students, this is yours. Pay attention up here so you can do your independent practice. Okay, negative 2, 5 is the vertex. We plug that into our vertex form here. 2 and then 5 into our vertex form. Negative 2, 5, and then 0.09. Since the graph passes through 0.09, we have 9 equals a. We're trying to find our a in here. So a would equal 0 plus 2 squared plus 5, and we solve for a, we get 1 equals a. So now that we have that, we can plug that in over here, and we get f of x equals x plus 2 squared plus 5. That would be the equation there. That would be right in standard form. This would be your standard form. Okay, on to page 4. Min and max values of quadratics. Consider this function here, vertex negative e over 2a, and then f of negative b over 2a. This is your x here, then this would be your y coordinate here. If a is greater than 0, then f has a minimum at x equals the negative of b over 2a. It has a min. If a is greater than 0, then if the min value is f of negative b over 2a. If a is less than 0, then f has a max at x equals negative b over 2a. So the max value is f of negative b over 2. Okay, let's take a look at one of these. The maximum height of a projectile baseball is hit at a point 3 feet above the ground at velocity 100 feet per second at an angle of 45 degrees. The path of the baseball is given by this quadratic here, where f of x is the height of the baseball in feet and x is the horizontal distance from home plate in feet. What is the maximum height reached by the baseball? So, for this quadratic, here's our standard form. We just plug in our values here. Then a equals negative 0.0032 and b equals 1. Here's our b here. So for negative b over 2a for our x coordinates, we plug in. We have negative of 1 over 2 times negative 0.0032. We crunch that number and we get 156.25 would be our x coordinate for the map parabola. So when we plug that back in to find our our y value, or the height, to find the height here, we plug in our x value here back into that quadratic, and when we crunch these numbers, you should get 81.125. So that would be our max there. And then this would be an actual parabola to model the path of the ball here. Y would equal 81.25. Here's your y coordinate for that baseball at 156.25. And this is like a screenshot from your calculator, what your calculator should look like. Okay, we're going to try one now for our guided practice here. Height of a projectile of a football in this case. Here is our model here of our parabola for football traveling. Use a graphing utility to graph the path of football. How high is the football when it is punted? What is the maximum height of the football? How far from the punter does the football strike the ground? And then this is your answer sheet here to do your calculations and enter your results on this page here, page 7a. Okay, so 2 points up there for your graph, and everything else here is 4 points. This is our solution here. So the graph, you should get a graph like this for that quadratic of that function. And then how high is the football? X equals 0, y equals 3 over 2 feet. How high is the football when it is punted? So when x equals 0, y would equal 3 over 2, or a foot and a half is where it was starting. Where it's punted at would be a foot and a half. And then what is the maximum height? So now we have to find our vertex here. We have to find this here. So negative e over 2a, we plug in our values. The vertex occurs in negative 9 over 5. That would be our negative b here. And then 2 times negative 16 over 202.5. So we come up with values here of 3645 over 32, and then in that case there, that would give us 113.9 feet here would be our x value. This would be our x value right here. That would be your x value for your vertex. Now we have to find our f of x here. So when you crunch these numbers, you should get 113.9. Now, to find our y, we plug that back in to our original quadratic model for the path of the football, negative 16 over 2025 times 3645 over 32 squared plus 9 over 5 times 3645 over 32 plus 3 over 2. And that crunches out to be in 104 feet. So your f of x value here would be 104 feet. How far from the punter does the football strike the ground? We want to find the distance between here and then here. We want to find the x intercept over here. So using a graphing utility, the 0y occurs at 228.6 or 228.6 feet. So it would happen right here. That would be using the grapher. You can trace it down to here, or you can go and find your intersect using your intersect menu. You can find it. This is 228.6. And that is your lesson for 2.1 part 2. Email me here for information. Thank you very much.